I'm always asked in these talks, you know, well, hasn't this been going on for a long time? You know, most ranchers will tell you we've seen dust on snow for, you know, ever since we've been on this place. And skiers will say, yeah, we've seen that every spring we've been out in the mountains. Well, we did this lake sediment coring in these high alpine tarns right next to Senator Beck Basin and in Senator Beck Basin to see if the sediment in these ponds had evidence of the dust at all, and then secondly, of rates of deposition that we could parse out and look at and hopefully see several hundred years, maybe more, of actual record in that sediment. And it turned out that actually we've got these guys, Dr. Neff from University of Colorado and Ashley Ballantyne from USGS found several thousand years worth of sediment in these ponds, essentially from the last glacial retreat onward. These are above any mining effects, so this is just inputs from local erosion and from the atmosphere. And sure enough, in that record, they saw it took a while for them to recognize the stratigraphy in the sample, but once they finally recognized, wow, you know, we've actually got several thousand years worth of record here, that up until western settlement of the Four Corners region, there was rate X of deposition, and it was fairly steady. There were a very clear pattern. And just as the Four Corners were settled, that rate X went to 10X within a very short period of time. And then just about at the time of the Taylor Grazing Act, which is maybe coincidental, maybe not, that rate went from 10X to about 6X. And that's about where they think we are now. But can't really tell in the last few decades because the sediments haven't, they're not distinct enough in the top of the sample. But there's no reason to think that it's any more or less than that. So probably we're at about 5 or 6 times the rate of deposition that this landscape experienced prior to western settlement of the Southwest. The other thing that his team did was actively collect dust in a filter, pulling air through this sampler continuously, and then analyze chemistry. They also used the lake sediments to analyze chemistry and our own snow samples, and were able to distinguish the dust signature in those lake sediments and in the snow as completely unique from the geology of the San Juan Mountains, and tie it really specifically to the Colorado Plateau through isotopic analysis and basic chemistry. So we're very confident that the vast majority of the dust in the San Juans and on up into the rest of the Colorado Mountains is coming from that Colorado Plateau source area. There may be very small traces of dust from the Mojave, which does leapfrog over into the Colorado Plateau and then maybe leapfrog on up here, and maybe even to the Gobi. But those particle sizes of the material that we collect are just much too large to have come from the Gobi. As the proportion of particle size, the distribution of particle sizes in our samples is so much larger than could possibly travel that distance, and the chemistry is so strongly attached to the Colorado Plateau that we're we're confident in identifying that as the source area. Just to sort of look at the potential effects of exposing the ground a month early or 50 days early on plant behavior in particular, we did an experiment with another researcher where we manipulated snowmelt in a couple ways. One was to actually sprinkle ground up rock from this geology on the snowpack, and just to sort of be sure that this experiment had really conclusive results, we guessed that, well, let's use 50 grams. This was before last year. And we thought, wow, this overkill, we're really going to, you know, this will be a dramatic effect. And then the other thing we did was spread out big sheets of black fabric, shade fabric from greenhouses that essentially allows about half of the light to penetrate through the fabric. Andrew hauled these 60-pound bales of fabric up to the basin, and we had some fun deploying those. And the result on this lower site, where the snowpack was really thin to begin with, was just what we wanted. We had about a 2-week advance in the melt-off of the snowpack. And then we got the fabric out of the, we pulled the fabric off and let the plants do their own thing, you know, with essentially without just altering the amount of water available to the plants. We didn't shovel these things off and steal the water. They still got the water. We didn't change the chemistry at all because the fabric didn't add any nutrients or anything like that. Even where we used the dust, we didn't really change the chemistry because it was the local native rock. So then Heidi Stelzer monitored the plant phenology, the life cycle of the plants on these plots all summer, right through when they started to die off. And her results were really interesting and showed not what we expected. It was an unexpected result where even though these plots were exposed, the plants didn't activate. They didn't start, you know, the photosynthesis did not get going. They stayed dormant. And then, as the rest of the snowpack went away, all of the plant community started to go off at once. And that's not the typical behavior. The plant community has evolved so that some species take advantage of early nutrient availability as snow is melting. Others delay. So there's a progression of life cycles that don't tax the system all at once. But in her plots, where we exposed the snowpack early, or the ground early, everything went off at once. So all of the nutrients available were being, you know, the whole system was trying to maximize at the same time, and the result was, you know, quite a bit different productivity in those plants. It's a really, you know, unexpected result that was published because of that, partly, and obviously begs for a lot more study. So, wrap it up here. There are things we have learned, and, you know, again, this is a short history of investigating this dust on snow and what's the effects are, starting in 03, 04. But we have learned that this is an extensive effect, an extensive process. This is not a spot effect.